You type a quick message to a friend across the ocean, hit send, and they read it a second later. From your perspective, the experience is seamless and instantaneous. Because we call our devices wireless, we imagine those messages traveling entirely through the air. We picture a signal bouncing through the atmosphere, flying straight from your phone to theirs, like invisible magic. But physics gets in the way. This animated diagram shows the behavior of a high-frequency radio wave. As it travels outward from a central point, the signal degrades incredibly fast. Buildings, trees, and the Earth's curvature scatter the energy until it fragments and disappears entirely within just a few miles. Because that signal rapidly weakens, your phone simply does not have the battery capacity or physical power to blast a radio wave across a continent, let alone an ocean, on its own. To bridge that massive distance, our perfectly wireless experience relies on a vast, completely hidden physical infrastructure to do the heavy lifting. The real journey begins the exact fraction of a second your finger leaves the glass. Your device instantly translates your text into binary code, simple ones and zeros, and blindly broadcasts it outward as a burst of high-frequency radio waves. Those waves only need to survive in the air long enough to reach the nearest local cell tower. Once the antenna on that tower catches the signal, the journey drops underground. The tower converts the airborne radio wave into pulses of light and pushes them down into a physical network of buried fiber-optic cables. This map illustrates where signals go next. Subterranean cables channel light pulses from peripheral towers into a centralized server hub, the mobile switching center. It acts as a digital post office, receiving a chaotic radio shout and sorting it into a structured, trackable packet. But the MSC immediately hits a logistical roadblock. It possesses your message, but it has absolutely no idea where on Earth your friend is currently standing. This flowchart illustrates the solution. The MSC holds your message and queries a database, the Home Location Register. It tracks real-time coordinates of billions of global mobile devices. Within milliseconds, it isolates your friend's device, locking on to their exact local cell tower. If the network tried to broadcast every single text message to every cell tower on the planet simultaneously, the entire system would crash under the data load in seconds. This specific database query prevents that collapse by narrowing the delivery zone to a single local target. With the precise delivery coordinates secured, the MSC injects your routed message back into the physical fiber optic network. This diagram outlines the message's return path. The data shoots away from the central hub, traveling through the underground cables at nearly the speed of light until it strikes the assigned destination tower. Deep inside the base of that specific tower, the incoming light pulses are translated back into their original form, a high-frequency radio wave. The antenna at the top of the tower acts like a lighthouse, sweeping that localized radio signal downward to blanket your friend's specific area. That localized signal intercepts their phone. The data makes its final airborne leap, completing the physical supply chain and crossing back into the wireless realm as their screen lights up. This animated sequence visualizes the full timeline: the air jump, the drop into fiber optics, the global database query, and the final air delivery all happen sequentially, in less time than it takes to blink. That data physically travels hundreds or even thousands of miles, routed by massive server farms and precisely coordinated across international lines, all in a fraction of a second. Because the instant gratification of modern communication is so reliable, we easily forget that we are permanently tethered to thousands of miles of buried glass cables and highly localized routing servers. Hitting send is an act of commanding a massive, physical, underground infrastructure to dynamically map the globe on your behalf.